So the concentration of a solution is really just some kind of a ratio of stuff to water. How much stuff do you have and how much water do you have? Doesn't have to be water, usually it is. So one simple way of expressing concentration is percent whatever by mass. In our case, it will be Kool-Aid. Percent Kool-Aid by mass. And anytime you do a percentage problem, it's always going to be part over total or piece over whole. But the part is your stuff, and the total is your stuff plus water. Okay? So if you had 10 grams of Kool-Aid and you dissolved it in 80 grams of water, that would be 10 grams of stuff divided by the total. What mistake are people going to make here? They're going to use 80 instead of using 90. You have to think. That's going to give you this decimal here. What I want you to do is to round to that spot right there and then move the decimal. You'll get the same answer if you move the decimal and round, but I think it's probably easier to just round to that second spot and then move the decimal. So that would be 11%. Now, a more chemistry type of concentration is this concept of molarity. And molarity is the moles of stuff divided by the volume of solution. Moles of stuff or amount. How much stuff do we have? And the volume of solution. Notice that it says solution. It doesn't say the amount of water. So the moles of stuff. What is a mole? A mole is a unit that we created to help us describe the number of atoms or molecules that we are dealing with, the number of things. Because atoms and molecules are really small, there's a lot of them. 1 mole is 6.02 times 10 to the 23rd things. That little e just means times 10 or exponent. It's this number right here. Half a mole is still that. 1/1,000,000th of a mole, if you divided this number here by 1,000,000, you still have a very large number. You don't need to get caught up in this number. You just need to know that a mole of things, or even if it's a half mole or a tenth of a mole or 0.01 moles, is a gazillion things, too many to count. But you do have to know that molarity is the number of things or moles of things compared to the volume of the solution. Similar to percentage, which is grams of stuff, if it's percentage by mass, grams of stuff compared to the grams of the solution. Now, since we're dealing with moles, you're going to have to find the molar mass. We don't count particles out. We weigh a collection of particles. It would take too long to count particles out. If you wanted to count this many particles, it would take you billions and billions and billions of years. So molar mass, the mass of 1 mole, or the mass of a gazillion things. Now, the way that we created this, chemists and scientists all sort of sat down and created a system. We use the mass number from the periodic table, to obtain the molar mass. If you look on the periodic table for carbon, the mass number is 12.01. That's actually a mass average because some carbon isotopes are 12, some are 13, some are 14. The overwhelming majority are 12. About 98% of all carbon atoms are C12. So this actually represents an average. Well, we don't want to use decimals. So why don't we just round those mass averages? Why don't we just take this mass average and we're just going to round it to a whole number and we're just going to use 12 because it's going to be easier. If you were to look at sodium, if you were to find sodium, if you were inclined to make sure that you understand this, take 5 seconds to find sodium, number 11. Some sodium atoms are 23, some are 22, and some are 21. Most are 23. So if we were using sodium, we would just round that to 23. So you can round the mass average. And that is also the mass of 1 mole. So if you had 1 mole of carbon atoms, which is 6.02 times 10 to the 23rd, that would have a mass of 12 grams. Now, we're not going to be dealing with elements, we're going to be dealing with sugar, because Kool-Aid is mostly sugar. This is the formula for sugar. Each molecule of sugar has 12 carbon atoms, 22 hydrogens, and 11 oxygens. We've seen a molecule of sugar before. It's this really large thing. It's got a double ring to it. You got all kinds of hydrogens and carbons and oxygens sticking off all over the place. So this is a big sugar molecule. 1 mole of sugar molecules is a gazillion molecules. How do we find the molar mass or mass of a gazillion sugar molecules? Well, if you have a gazillion sugar molecules, you're going to have a gazillion carbon atoms. You're going to have a gazillion hydrogen atoms. You're going to have a gazillion oxygen atoms. In fact, you're going to have more than a gazillion carbon atoms, more than a gazillion hydrogen atoms. But the way that you find that out, you have the number of atoms from the formula, and you just multiply that by the mass that you've rounded to on the periodic table, the molar mass. And then you add all that up. So 1 mole of sugar molecules, or a gazillion sugar molecules, is 342 grams. 10 grams of sugar, which is what we were using approximately to make our little Kool-Aid solutions, is how many moles? Well, if you want to take your actual amount and you want to convert it to the number of moles, you take the actual amount and you divide it by the molar mass. And that's going to give you this number here. That is the number of moles. Now, we don't want to use something like that. That's what you're going to get on your calculator. So let's agree to round it to a decimal that has 2 actual numbers in it, so 0.029. And then if you were to take that and dissolve it in a half a liter of water, this would be your molarity. If you were to dissolve it in more water, this would be your molarity. And if you were to dissolve it in even more water, this would be your molarity. So your concentration went down as you increase the amount of water, which is what would happen. So that's a quick run through on molarity.